In part 1, link in the description, we talked about how over time pockets in the universe will form huge galaxies and drift away from each other, as the universe expands infinitely and exponentially driven by dark matter. Now let's talk about entropy. To put a complicated thing in simple terms, entropy, in the context of thermodynamics, is a universal law that states that things in the universe don't like having a lot of energy. They are constantly trying to move into lower energy states, giving off the energy as electromagnetic radiation, what we perceive as light. Since there is a finite amount of matter in the universe, or at least in the observable universe, eventually there will be no energy left. All the matter that is close enough to us to be relevant will have given off all possible energy and moved to its highest entropic value or its lowest energy state. This will happen to every form of matter, even black holes. This was found out using mathematical predictions by the great physicist Stephen Hawking in 1974, and is therefore called Hawking radiation. Again, to put a very complicated matter simply, empty space is not empty, even in a perfect vacuum. At the smallest level, there are virtual particles that pop into existence and then annihilate each other. At the event horizon of a black hole, and we will go into more detail about black holes in another video, one of these particles is pulled into the black hole and one is ejected into space. This causes the black hole to lose energy. However, this process happens mind-numbingly slow, and in fact slows more and more the size of the black hole increases. For the supermassive black holes in the center of galaxies, it could take as much as 10 to the 100 years to evaporate. Let that sink in. It's a 1 with 100 zeros after it. However, it is a finite amount of time and therefore will eventually happen. Stretching the timeline even more, if neutrons don't decay, some models do have this happen, but in the current accepted model of particle physics, the standard model, they do not. Therefore, we will assume that they don't, at least for now. All atoms will eventually turn into iron-56 isotopes, the most stable atom, over an amount of time so long, numbers barely make a difference anymore. After this happens, the universe will effectively be dead. The universe's expansion will have sped up so much and have had time to grow the universe to unthinkable size. The universe will simply be a void filled with single iron-56 isotopes separated by effectively infinite distances. The universe will have at this point reached its maximum entropy. Nothing else can ever happen. At this point, the universe is dead. Time, for all intensive purposes, will have grounded to a halt. Structures any larger than atoms will not be able to form, therefore destroying any chance of life. However, there are ways civilizations could exist longer than this in theory. We will talk about that in a future video. There's also a theory we have called the Big Rip that could destroy the universe in a comparative eye blink. We will also have a video on that. Thank you for watching. This is Abstractual, where we talk about our beautifully destructive universe. Please like, share, comment, and subscribe if you enjoyed.